Hello everyone, fantastic to be here and even better to see such an awesome crowd. So thank you for coming to my talk. My name's Patrycja and today we are gonna explore live Kubernetes hacking together. So get ready for a ride. First, a brief introduction. I've been doing professional software development for over 25 years, so I do feel like a vintage dinosaur. But hey, who doesn't love a classic, right? I've always been close to code, and that bond still thrives today. However, over 2 years ago, I joined the dark side of platform engineering, and guess what? I absolutely loved it. Today I'm a staff SRE engineer at Form3. So what do we do at Form3? Uh, Basically, Form3 is a financial cloud. We provide payment as a platform model for quick and easy integration with various payment schemes via REST API. We are technology-oriented, cloud-based, fully remote with microservices architectures. Recently, we've built this new multi-cloud payment platform based on Kubernetes and free clouds. So basically, Kubernetes security is super important to us. What am I going to talk about today? Just a splash of theory in the ocean of practice. The key part of today's talk features free demos when I will try to hijack your accounts, exploiting various misconfiguration and security vulnerabilities in my Kubernetes cluster, as well as Kubernetes application. But first, to be on the same page, let's do a quick review of Kubernetes architecture, just to know which components should we target first. So basically, there's two main concepts in Kubernetes, the control plane and worker nodes. Control plane is responsible for the management of the entire Kubernetes cluster. So if you want to interact with your Kubernetes cluster, like you want to create or update any resource, you need to interact with the API server. So it's like the heart of our Kubernetes control plane. This is like an HTTP-based API. You connect to it via kubectl. Who knows kubectl? Like everyone, yeah? Another important component here is etcd. etcd is a key value store, and basically it stores all information on all resources in the entire cluster. So think about all your secrets. Those are stored in etcd. So once a hacker gets their hands on etcd, they can read like all secrets. So on the other hand, we have worker nodes. Worker nodes are the place where the actual work happens. So all the pods are running over there. And the main component on this side is kubelet. Kubelet is deployed to each and every worker node and is responsible for instantiation and execution of all the pods. Similarly to the API server, kubelet also exposes this REST API, but this is only an internal API. But think about another attack vector. When you connect to this, for example, unsecured kubelet API, then you can read all the information about the pods running on this particular node, or you can instantiate and execute a new pod. So a sneak peek, we will exploit this unsecured kubelet API to get access to the pods running in our Kubernetes cluster. Another important aspect of Kubernetes architecture is networking. So most likely you are aware that Kubernetes exposes this flat network security model. What does it flat mean here? Basically, it means that each and every pod can communicate with any other pod in a cluster. That's by default. So if you run like several workloads in the same Kubernetes clusters, basically they can communicate with each other if you don't implement any other security mechanisms. But this it may be useful to understand how this networking is implemented, because this is potentially another attack surface in our Kubernetes clusters. So basically, to implement this flat networking model, Kubernetes makes use of CN9, Container Network Interface. That's only a spec. And you have like different implementations of this interface. So most likely in your clusters you run like Calico or Flannel or Cilium as CNI providers. So those CNI implementations, they create like an overlay network over your host network. And this overlay network provides a way to communicate, provides a way for communication for pods. And usually those overlay networks are created via creation of new virtual network interfaces on hosts, and then modification of IP tables or like eBPF injection rules that allow to forward traffic from one pod, one IP to another pod, another IP. So that was like a very quick introduction to Kubernetes architecture, and I managed hopefully to highlight some attack surfaces we will target in our Kubernetes hacking demos. But what could go wrong when it comes to Kubernetes security? Let's take a look at Kubernetes top 10 risk. Who knows OWASP? Yeah, quite many hands raised up. So OWASP stands for the Open Web Application Security Project. This is this non-for-profit organization which aims at increasing security awareness among developers. And they started with web applications, but they moved on to new technologies as well. And they publish those top 10 security risks for various technologies for many, many years. But in 2022, for the first time, they published this top 10 security risk list for Kubernetes. And this is like hit parade. So let's take a look at chart toppers. Number one here is insecure workload configuration. So basically how you configure your workloads deployed in Kubernetes clusters. So usually it's about root user, writable file systems, privileged mode, and any extra configuration that allows to access any resources from the underlying hosts, like for example host network, host volumes, etc. And this is like the main number one source of any security vulnerabilities. Usually it's related to K4, like of centralized policy enforcement. So basically, if you don't have any way to reject a misconfigured workload in your Kubernetes clusters, most likely it means that you are like open to some exploits. Also, usually we have problems with K7, missing network segmentation controls. I told you about this flat network security model. If you run like multiple workloads, separate workloads in the same Kubernetes clusters, issue in one workload can lead to a compromise in another one. And also secrets management failures. You need to remember that your Kubernetes secrets are not encrypted. They are only encoded. So basically once someone, most likely malicious hackers, get access to your Kubernetes secrets, they can read them like in plain text. So that's also very important. And popular aspects like misconfigured cluster components or outdated and vulnerable Kubernetes components. That happens very often also, however less likely when you have like managed Kubernetes in clouds. Although it's always worthwhile to keep an eye on updates and what versions of Kubernetes and applications you are running inside your clusters. Okay, so let's move to the fun part. Like it's gonna be like 101 in Kubernetes hacking. So mostly basic techniques, but hopefully it will open your eyes and show you the danger how a series of simple misconfigurations can lead to a compromise of your entire cluster. So I have this demo application and I will need your help here. This demo application is available at jnation.yonlabs.com. You can scan a QR code and I have a kind ask to you. Please register a new account, log in and wait to be hacked. My objective here is to hack your accounts and learn your secrets. I give you like a moment to scan QR code. You can go also to my ex-Twitter account, Yon Labs. There is a link available there as well. And this is the application. This is like very simple web application. Obviously use a nickname. Do not reuse any of your real passwords. Those could be leaked during our demos. And let's log in. And okay, I was to say that I will wait for you to register, but I'm already seeing new accounts. So I do have some accounts waiting to be hacked. Thank you. So let me move to my evil server. This is a server from which I will do all the hacking. And basically, this server is in the same private network as our target Kubernetes cluster. What's the first thing the hackers do once they get some first foot inside? It's usually some sort of reconnaissance. They use tools like Nmap, just to scan open ports to see what's available, so some sort of reconnaissance. Here we are using, we know that we are targeting a Kubernetes cluster, so let's use a dedicated tool and scanner for that. That's kubectl. And just like kubectl, kubectl is a wrapper which allows to access this REST kubelet API I mentioned before. So here I'm scanning my private network just to search open kubelet APIs. I'm scanning only like a small side range. Why? Because I don't want it to take too long. We do have limited time. And surprise, surprise, we do have an open kubelet API here. So if this is kubelet API, we know this is like REST API. So basically, let's use curl here and connect to it. Basically, I will use pods endpoint just to see all the pods. And I just need to filter them and see what's available. Okay, so those are all the pods running on this node. What can I do more here? Basically, this kubectl. So kubectl has several options. And for scan, we can scan for RCE, remote code execution, or for tokens, so like any tokens I could get access to in a given node. This would mean like privilege escalation in case of like some tokens which have like some service accounts which have like higher privileges. So that's one attack vector. However, this time I will target and search for like remote code execution inside our pods. What remote code execution means in this context? Basically, it means that I can execute, that there is a shell available and I can execute any command inside this shell of a pod. So I'm scanning my my server cube and this node to find RC pods which allow for RCE. And I do see some pods here. One more thing here is you see that this Kubernetes cluster is running Calico CNI, and by default Calico allows to execute commands, so it allows for shell and command execution inside a pod. But I'm targeting my demo application. So I do see 2 pods at least related to my demo or even more. So one is demo web, demo server, backend, and Redis here. So let's take a look at this demo server. So I want to run like first who am I inside this pod. Okay, let me do that, and I need to provide a lot of parameters. Oh, lucky me, I'm root here. So that's very fortunate. And what can I do more here? So basically, now I would like to get access and to have like more comfortable working environment here. So what can I do here? Basically, once a hacker sees like a remote code execution, they go for a reverse shell. What is a reverse shell? Basically, if you have a remote server and you want to connect to this remote server from your client machine, you SSH to this machine, you provide credentials, and you are given a shell. A reverse shell is the other way around. So instead of a client machine connecting to a remote server, this is a remote server connecting to a client machine. This way we are bypassing this credential step. I wanna get this reverse shell inside this pod to see and to have more comfortable working environment. So I need a reverse shell. To connect from inside a pod to my client machine, evil server, so I need some process to listen on my evil server. So I have the second session here. I will run ncat just to listen on this 4.4 port. And here in my second terminal, I will connect to my evil server on this port 444, and I will expose shell, execute shell. Okay, connection received, we are in. So basically we are inside this pod now. So again, some sort of a reconnaissance. Who am I? I know I'm root. This is not like fully interactive shell, so it has some limited capabilities, especially when it comes to like command history or like streams. I don't have access to standard error. I have only access to standard output. However, I can work around this and see what's going on here. I do see that this pod is not in privileged mode. I don't see like mounts characteristics to this privileged mode. I can see what's listening here. We do see one process listening on port 1990. So it would be good, for example, to sniff traffic here. However, for traffic, I need like, for packet sniffing, I need like TCP dump. Do we have this one? No, we don't. Here this redirect is because we don't have access to standard error, so I wanted to see like an error message here. We don't have TCP dump, but we are root, and the question is does this pod have writable file system? If this pod has a writable file system, we can install what we want. So, for example, TCP dump. Touch write tests. Yes, this is like writable file system. So let's give it a try and let's install TCP dump here. Okay, it looks like it's been installed. So now let's make use of it. And let's like listen and sniff traffic on a 1990 port. Now I need your help here. Please refresh the pages in my demo web app. And here I see some traffic coming in. So thank you so much for the cooperation. And let's see what's coming here. So we see this authorization bearer token. So those looks like JWT tokens. And let's see if that's right, that this is probably the token from our application. Yes, that's correct. You see that this application uses JWT tokens based on the look of a token. So let's try to replace my token with one of yours and see what happens here. So just copy it and let's refresh the page and test 1, 2, 3. You've been hacked. Are you here? Thank you. That was very effective cooperation. What have we seen here? First of all, let's take a look at Kubelet API docs. So we've seen this open Kubelet API, and those are the defaults. Those are the snippets from Kubernetes documentation, and you see that anonymous auth is defaulted to true, and authorization mode defaults to always allow, which basically means full access. It's not that bad as it looks here. Why? Because though this open kubelet API is only when those defaults apply only when you install Kubernetes by hand. Usually when you use managed Kubernetes in clouds, those have secure defaults, or if you use like proven installation method, like some framework or tool like kubeadm, you are good. Those usually have secure defaults. On the other hand, if you have like some custom Kubernetes installation, bare metal installation with some custom installation procedure, it's worthwhile to check out your configs whether or not they allow for this open kubelet API. And we had a bunch of misconfigurations on a container level. We had this writable file system. You see that once you have a writable file system, and a hacker or malicious employee gets access to your pod, they can install whatever they want. So running as root is also like a no-no. Exec into container, quite a few tools available which made this reverse shell possible. But still the root cause would be writable file system. Another issue is like networking. We observe unencrypted traffic inside a cluster. So even though when you take a look at the link to connect to the web application, you see HTTPS. But this HTTPS connection ends on a load balancer here. And inside a cluster, like it's all like plain traffic. So I don't remember how many times, but it was, believe me, many times I had this talk with junior DevOps or software engineers that we were arguing whether or not to encrypt traffic inside the cluster. Yes. If you have like any sensitive data and you care about security, you need this defense in depth principle, and you need to have multiple security mechanisms implemented, and encryption is one of them. And another perhaps more subtle issue is open egress to internet. So basically, I was able to download TCP and install TCP dump. I see a hand raised, but perhaps let's leave all the questions to the end. Is that okay? Okay, thank you. So be careful about like open access to the internet, because you see this is like not a single vulnerability. it's a series of simple misconfigurations. Okay, let's move to demo 2 now. And this second demo, it makes use of a different application deployed in the same cluster. And basically, this is a simple hello application. I type my name and it responds like, hello, Patrycja. But what if I type something like that? If I try to execute remote code here, I'm in. That's the response is www-data. So basically it suggests that underneath there is HTTPD server because www-data is a default user for HTTPD server. So we have a remote code execution in another workload running in the same cluster. So it's like I'm a one-trick pony. So let's go for reverse shell again, right? So here, let me see the IP of my evil server. So you know that I need this NC process running on my evil server. And here I will try to construct a remote code execution to connect via NCAT to my evil server. So I need this one. Okay, connection received, and that's very handy. And you see that I'm in. Let me double check who am I, www-data, that's very handy. I do see mounts here, and here you see those mounts suggest that we are in this privileged mode. But what can I do here? But I'm only www-data user, I'm not root here. So let's scan our network. And I have a cheat sheet for this one to make it a little bit easier. So I will scan open ports and I will target on only like a subset of the network because otherwise it would take too long time. And I'm looking for this 6379 port open. And yeah, surprise, surprise again, right? You didn't expect that. So we do have an open port and it points to Redis server. So and that's this demo Redis server. So basically this is most likely for our demo application. What's going on here? We have this open and flat networking model here. And we see that we can connect to this Redis server. Let's make use of those Redis commands to see if actually we can execute them. So this is just like ping commands, echo commands, so it checks the connectivity. Yes, we are in and we can connect to Redis. We can see all values stored in Redis. Let's do them. We don't see anything here. So I have another ask to you. Please log out and log in again. Why? Because if you know a little bit about JSON Web Tokens, you know that with those tokens, if you want to implement a logout option in your application, and you should care about that because any secure application should provide a way to terminate a session for a user. So you need to have some logout option. And with JSON Web Tokens, you have a problem because there is no way to invalidate JSON Web Tokens. So usually how it is implemented on the server side, that unfortunately the state strikes back and you need some storage for invalidated tokens. Usually applications use like short-term storage for those tokens, so Redis is a good fit for those tokens. And basically those invalidated tokens are stored in some sort of invalidated store. Once user wants to log in or uses a token, this token is checked against the store whether it's been invalidated or not. Okay, so I do have a bunch of tokens here, and my suspicion is that this is the store used for invalidated tokens. So I could reuse one of those tokens, but I need to first delete one of them, delete from the store. And then I could safely reuse them. So let me delete and prepare a command to delete it. Okay, it's been deleted. Let me grab it and let's try to use it in our application then. Let me refresh. And Tudor, you've been hacked. Are you here? Yeah, thank you. And congrats. You see that remote code execution in one Kubernetes deployment could lead to a compromise in another workload running in the same cluster. So we had a couple of issues here. Obviously, RCE being one of them. Another one was missing network segmentation. So via this hello application with RCE, we could easily connect to another namespace in Kubernetes where our demo application was deployed into. So that's a problem. We shouldn't allow that, and we should apply network policies to avoid those kind of issues. Or even if you have very sensitive workloads, you could think like to segregate them and deploy into separate Kubernetes clusters. Again, on the container level, we had quite few tools available. Reverse shell was possible, and again, anonymous access to Redis. In our demo, it served as a store for invalidated tokens. So even though it's inside your kind of protected cluster, you see that like 1 foot in, and we can like work out our way farther and farther. Okay, so now it's time for our third demo. Let's get back to my evil server. Let's switch to user John Doe. This user John Doe has like a limited permission in our cluster. They have access to the cluster. They can execute some commands, but only limited permissions. So let's check out what permissions this user has, and again, a little bit of cheating, and I know the namespace I'm interested in. So basically, this user has permissions to deployments, pods, and pods exec. So that's very handy because when we have this access, we could, for example, try this one. So we could deploy this handcrafted pod, which is deployed in privilege mode and has host PID set to true. Obviously, it runs in as root because we haven't set any other user here. So by default, it's root. And we are trying to schedule this pod on a control plane here. So let's apply this manifest. Oops, sorry. Yeah. Okay, I have this one running, already running, you see unchanged. So let's try to exec into this pod. And I just want to have some shell. You see that I'm at the moment on this pod. And what can I do here? If I'm in a privileged mode and I have host PID set to true, this means that I have access to all the processes running on this host, and specifically I'm interested in this process number one because this is like an init process, and I could enter the namespace of this process and or rather all namespaces, because if you know a little bit about Linux security, you know that it's based on namespaces. So basically, if you have like some sort of container on your Linux machine, this is basically a different namespace. So to escape a pod and escape to node, I need to change my namespaces to one of those of the underlying host. So this number one process is a good target because this is like the main process there. So I'm trying to execute bash in the names and enter the namespace of our init process. And you see here, now I'm on the node. So basically, I have full access to what's running on the node together with volumes, even though the volumes were not mounted. So basically, now I'm, at the moment, I'm on the host. I'm still interested in this, in the processes, but I'm interested specifically in etcd. I do see etcd here running, and what I'm interested in is like, I'm interested in this one because basically it says what data there, all the information are stored. This is a key value store, but it has the snapshots on the disk as well. So I am on the host, so I can just access etcd. And basically here I see all the etcd data, and I can read the database, the key value store, just like that using strings command, which shows me like the content of a binary file in a string format. So I've already mentioned that I'm interested in secrets here. Yeah, again, lucky me, I do see some secrets. So let me grab and see a little bit more on our demo secret. Okay, I do see our full secret here. So that JWT secret key. So let's take a look here. Again, I will log in as Patrycja. And I will show you the content of our JSON Web Token. So basically here this token uses HS256 algorithm. This is a symmetric algorithm. So basically to generate a new token, I need this secret key. And lucky me, I've got this secret key here. So, surprise, surprise, let's try to generate a new secret here. This set of claims usually somehow represents a user's identity, and usually that's a subject claim that's responsible for user ID, something like that. So let's switch it to lucky 7. And that should be my new token. And let's try to use it. And Batatina, you've been hacked. Thank you. So you've seen like root combined with privileged and host PID allowed me to escape to node. So we had also a problem that even though I was a user with limited permissions, I still was able to create this unsecure workload pod, which allow me to get access to cluster and then escape to node. So, here we are lacking some sort of centralized policy enforcement, some admission webhook, which could reject misconfigured workloads. And obviously, secret management failure, you see the most secret is not encrypted, it's only encoded, so we need to account for that as well. You've seen a couple of issues here, and that's only like the tip of an iceberg. I could go on and on Kubernetes details, but hopefully you've seen like a series of simple misconfigurations can lead to a compromise of an entire cluster. We managed to escape to nodes, so basically the sky is the limit. At that moment, we could do anything we want. We need to keep in mind the Swiss cheese security model is not like only about one layer of security. It's about like those Swiss cheese slices. So to cover the holes in one slice, we need like many slices. And it's not about like having 100% guarantees that hackers won't get to our clusters. It's not possible. But it's like making it easier for us good guys to see and detect any threats or attempts of attack early on and make it like worse for bad guys to get into our clusters. And we need to remember that a fool with a tool is only a fool. So we as DevOps software engineers, we need to use our tools wisely. So we need to understand how they work underneath and what security measures we need to apply to make them better and more secure. There is like many continuous paradigms in software development. You know, continuous integration, you know, continuous delivery. I often talk about continuous refactoring to make our code better. But the fundamental paradigm here is continuous learning. So we need to keep educating ourselves. And basically, that's what conferences are all about, right? So let's keep learning together at JNation. Thank you for such an effective cooperation. And feel free to grab me during a break and ask any questions. Yes?
So, great. I have a couple of questions, but the first one that I raised the hand was regarding the SSL termination. So you suggested not to do it on the load balancer or the ingress or something like that, but inside the pod, correct?
Sorry, could you please repeat?
The SSL termination, where do you terminate the certificate? Your suggestion was to have the traffic encrypted even though it's coming to the pod.
Yeah, so basically I don't suggest to terminate SSL client-customer session inside a pod because I'm only saying about that all internal traffic should be encrypted. So you could have like this HTTPS client session termination on some load balancer, but still you need like some internal traffic to be encrypted as well. So use some sort of HTTPS or any other encryption depending on the protocol you use. So it's not only about termination of SSL far inside the traffic because it's not always possible, especially if you have a set of microservices working together, but it's all about encryption of all internal traffic as well.
Yeah. Great, so where do you store the certificate or whatever it is, the private key or public key or whatever you use to decrypt the traffic? Because if you store it again in the pod, for instance, a malicious hacker, if they executed a remote shell in the pod, they will receive the encrypted traffic but with the TCP dump, but they can also have the certificate because they are inside the pod and still decrypt it by themselves.
It depends. You could make, well, obviously, if you are inside a pod, it's difficult. But here, you see that I've used like I could use like I've used TCP dump on this pod, and basically, once you are on a pod, it's difficult to protect if you have access to a private key. You could limit this access, avoiding mounting private keys inside pods, and instead of mounting as secrets or volumes, you could use some tools like Vault to read it only on the application level. Still, it could be a skilled hacker could be able to like get access to that, like memory dumps and that kind of stuff. But it's not like a perfect security, but you are making it more difficult.
Yeah, my concern is that maybe you're making security to obscurity, so a skilled hacker can still be able to decrypt the traffic, but you make it harder for your developers because they need to maintain keys here and there.
Nope. Nope. It's not only about definitely that's not security by obscurity. It's all about in case of unencrypted traffic, the case I showed you was on the same node. So I could get access to, for example, a private key in some way. But it's not only, this traffic not only goes through the node where the private key sits, right? It goes through all the other machines and hops through many like internal points. And if you don't use encryption, then you have a plain traffic which could be sniffed at any point. So definitely that's not security by obscurity. And security comes with a price. It's not super user-friendly, and it makes our developers' lives much more complicated in several cases. So it's about also tooling to make it easier. We are running out of time, so we could take our discussion to the break, and happy to discuss any more questions if you have.